Hi, welcome to the first part of the lesson on confidence intervals. Um, to give you a little bit of context, we've just done descriptive statistics and probability, and the rest of the course is on methods of inferential statistics. Inferential statistics comes from that root word infer, which means we are inferring or generalizing from a sample to the population. So there's two tools we look at. One is confidence intervals, and we'll do that this week. And the second one is hypothesis tests, and we'll be doing that pretty much the whole rest of the course. But for now, we're looking at confidence intervals. So some things to review before we get started. A statistic is a quantity based on a sample, so like the sample mean. And a parameter is a quantity based on the population, so like the population mean. So some notation that we've seen, but it's important for you to know now. And if you don't have this already in your mind, write it down and keep it handy. X bar is the sample mean, mu is the population mean, S is the sample standard deviation, and sigma is the population standard deviation. So again, if you don't have that where you can access it in your brain instantly, write it down where you can have it, where you can access it outside your brain. All right, confidence intervals consist of two things. The first thing is a point estimate. A point estimate is if we had to pick one number to be our best guess for the parameter, that would be the point estimate. And really the point estimate is just the statistic that corresponds to the parameter we're looking for. So if we want to estimate the population mean, mu, all we have to do is use the point estimate, the sample mean, x bar. All right, so x bar is the point estimate for mu, and S is the point estimate for sigma. For right now, we're going to focus on the mean. So with the nature of sampling, we would expect to get a sample mean that's going to be pretty close to mu. But it's really not going to be exactly mu most of the time. They call that sampling error, which isn't a mistake. It's just the nature of sampling, is that you're not going to get a sample mean that's going to be exactly equal to the population mean. A confidence interval gives us an interval that we think that we are usually 90, 95, 99% confident includes the value of the parameter. So we said there's two parts to a confidence interval. One is the point estimate, and that's x bar for the mean. And the second part is the margin of error. And I'm sure you've seen this before. I'm confident you've seen this before. Anytime they ever say, candidate X is beating candidate Y by however many points with a margin of error of, 2 points or something, that means this is what they think the answer is, but they think it could be off by as much as the margin of error in either direction. We also write confidence intervals in interval notation. So we'll write it as x bar minus the margin of error, comma, x bar plus the margin of error. So for now, we're just going to look at these in SPSS, and then we're going to look at them in the next lesson in StatCrunch. All right. So this output comes from SPSS using the explore function, which you've seen before. So for the number of hours per week spent watching TV, they give us the lower bound and the upper bound. So this is how you'd write it. You'd say the confidence interval is the lower bound, which is 7.7727 hours, up to 10.7273 hours. Right? So I want you to be able, from looking at the output, to determine what is the margin of error. So we have our confidence interval at 7.7727 up to 10.7273, and we know our sample mean. If we work backwards a little bit, just take the upper limit minus the sample mean. That'll give you the margin of error. Okay, so that's the upper confidence limit minus the sample mean. That's one way to get it. It's not the only way to get it, but so the way you would write the confidence interval in margin of error notation is 9.25 plus or minus 1.4773. So now let's look at interpretation of the confidence intervals. So we've got our two numbers here. There are some variations on how we can interpret that. We could say with 95% confidence, or we are 95% confident that the population mean amount of television watched per week is between those two numbers. There are some things that we need to be careful of, though. There's not a lot of room to be creative here with your interpretation of confidence intervals. So some incorrect interpretations. One is the use of this word falls. This seems like a picky detail, but the word falls makes it sound like the population mean is random, when in fact mu is actually a fixed quantity. It's the sample mean that's going to fall somewhere. Anyway, so just avoid the use of the word falls. The next one is a really big deal, though. We're 95% confident that the mean amount of television watched by this sample of adolescents. It's very, very incorrect to say this is the sample of adolescents, because we're trying to infer about the population mean, not the sample mean. We know what the sample mean is, and the way we construct our confidence interval, it's right smack dab in the middle of the confidence interval. So it's always, we are 95% confident, or whatever percent, that the population mean is in the interval. There are a couple of other variations on this. We're 95% confident that the mean watched by the 30 adolescents, or however many there were, is in the interval. Just be careful with your phrasing there. Make sure that you're indicating it's for the population. Finally, the last one, 95% of all adolescents watch between that amount of television. This is not a correct interpretation, because we're not talking about how many adolescents watch in that region. We're looking at how confident we are that the population mean is in that region. So in order to use this confidence interval, we need a couple of things to be true. And you'll recognize these from the central limit theorem, I hope. So we need either a large sample size, greater than or equal to 30, or we need to know that the data comes from a normal distribution. And you can get that by looking at a histogram, or most likely you'll be told in a given problem just to assume it. So we can look at SPSS output to see if the assumptions are met. In this one, we've got a sample of size 40, so that means we're fine. So we've met the assumption to run the confidence interval. If it hadn't been, we'd have to look at the histogram. If it's not too far from normal, we'd still use the confidence interval. Otherwise, we really shouldn't report the confidence interval if the assumptions have not been met. Last thing in this lesson, based on a confidence interval, we can determine whether a particular value of the parameter is a reasonable guess. So in our example, would it be reasonable to estimate the population mean to be 8 hours? Well, our confidence interval was 7.7727 up to 10.7273. 8 is in there, which means, yeah, it's a reasonable guess. So the next question, would it be reasonable to estimate the population mean to be 11 hours? Well, no, because that's not in the confidence interval. All right, so that's it for this lesson, and let me know if you have any questions.